Okay, so good morning, everyone. I'm giving this presentation for the T2 team that you see here. The PIs are here. This is robotics as we know it, and it's a fantastic kind of technology, so reliable, so effective. There are jobs that cannot be done without robots. Robots can really build the most of the objects of our daily life today. But there are still jobs that are done by people and cannot be done by robots yet. And sometimes those jobs are not so good for people because they're dangerous or just because they are not meaningful. So you know that M3S starts from the consideration, that we now have a very rapid progress of robotics technologies, of AI, and we can take advantage of that to help people at work. So more specifically, you have heard already that M3S is having these two big research questions on how we can take advantage of that and how we can we should change the way we work and the policies and the institutions. More specifically, in M3S, T2 investigates how robot can assist human workers and investigate forms of human-robot interaction at work with cognitive and physical tasks and forms of interactions. So the reason why there are jobs still done by human beings is that there are abilities that are not yet reached by robots. So in scenarios like this one, are our robots, current existing available robots suited for the tasks? Maybe not yet. What are the gaps? So what we observe when we observe living beings are complex systems operate in very complex environments, which is a bit different from what happens in robotics, because in robotics we think that when we have a complex system, then it is more difficult to control and it is more likely, not to work. So we try to simplify as much as possible. And in the same way, we try to simplify the environment in robotics. So the factory environments we saw at the beginning, where robots work so well, is sort of simplified and adapted to the robots. But instead, in nature, we see the opposite. So very complex systems. Those living beings are way more complex than any robot in terms of sensors and muscles to control. And the environments are also complex, reward environments, but their behavior is so smooth, so effective. So this is exactly what we should do in robotics. So we should build robots as complex as needed for the tasks they are supposed to do, and they should be able to operate in real-world environments. We can take lessons from nature. We can try to find the tricks that nature put in place to simplify the control, not the system, not the environment, but the way it works. And this is the direction we are taking in T2. So we are working at two levels. One is the level, let's say, of the body. So we are exploring soft robotics technologies for building our robots, because they give us the possibility to implement embodied intelligence, so to distribute intelligence in the body itself and simplify control to some extent, and also take inspirations from some brain mechanisms. So basically in T2 we are addressing some research challenges, research problems that are more related to the brain of the robots. So they include all the perception capability, but also the way they control their behavior, they navigate in narrow spaces and real-world environment, and the way they can learn. They can learn how to accomplish tasks. They can learn from human beings. And we also address challenges in the way we design the body of the robot, the kind of technologies that we use. And especially at some point we'll merge the two, especially for exploring new forms of human-robot interaction, which is very much based on learning from the human workers, and the way tasks are accomplished. So this is a quite general concept that we have at the moment for our robot that can be used as a support for human workers. We actually are instantiated this concept on very specific use cases. We have collaborated with industrial partners in this. So we started with the description of those use cases and the observation of the work environments and the tasks. And then we are now refining our concept. We refined our general concept that you saw to instantiate it on the use cases. We already had some feedback from our industrial partners, and we are now entering the phase of a more detailed design and then the fabrication and testing of the robots. So the potential applications are many. So we are, as I said, it's a quite general concept that we can not only implement in the use cases that we are addressing, but we can extend to other possible applications in, as I said, real-world scenarios. So it's not only the manufacturing industry, which is, however, one of the possible settings, but also some other tasks like service tasks or assistive tasks. So that's quite all. As I said, we want to take advantage of the rapid progress of artificial intelligence and robotics for having machines, robots that help people at work. And specifically, we are investigating how soft robot can assist human workers. So we think we can investigate new forms of human-robot interactions that are also based on physical kind of interactions with soft robotic arms that can be used by workers as a tool, and provide them with appropriate, adequate perception and intelligence for understanding and for interacting with human. This is the full list of the team members in T2, so the PIs, but also the researchers that are actively working on this concept and the robot. Thank you.